In Matlab, we have the possibility of calculating and also the possibility of illustrating the wind pressure using some different codes, right? In the video, I'm gonna show you how to code the wind pressure in Matlab. First of all, we have to start a new project, like we have to start a new, and from the new page, we need to list all the parameter, all the unknown parameter, all the given parameters, right? So I list all the parameters that I need to use in this coding, and we can see that I have the altitude, I have the temperature, and the humidity, and also I have the wind speed, I have the building height, I have the building length, and also I have the city. So the city is the drag coefficient, right? And it depends on the shape, and the surface roughness of the structure, right? And it can be defined according to the codes, like different codes, different city, different location, right? And here there's no problem, right? So you have to find all the value corresponding to your altitude and all the given here, right? And also, first of all, I want to clean my comments window, right? So for cleaning the comment window, I need to put a CLC. And after that, I need also to clean the workspace. The workspace, I need to use I need to use clear, right? Clear, right? And our first step that I said, our first step is about the given parameters, right? So I define my given parameters. So my main objective is to find the wind pressure, because this wind pressure can be used in order for us to determine the wind loads on the structure, right? So we have to find the wind pressure, right? And the wind pressure, before I find the wind pressure, we have the main unknown. So the unknown that we need to find here is the air density, right? And this air density, the air density is rho, right? It's represented by rho, right? In the Greek alphabet letter, like rho, and it can be defined in three possibility, right? So the first one, like the first possibility, like the overall. Let's go about the overall structure of rho. So rho, or the air density equals to the air density, right? It should be, listen up. So it should be the air density. So the value should be the air density, right? The air density should be the air density, but this air density should include all the parameters. By all the parameters should be include the altitude, right? The altitude, right? Sorry. And also the temperature, right? And after that, also the last one is the humidity, right? So in order to find the rho, we have to come up with the formula that includes the altitude, the temperature, and the humidity, reading the code, different codes, and also following the geography codes, right? And also the construction codes, right? So here, I'm gonna close it. And this the air density. And after finding the air density, I'm gonna find the wind pressure, right? So let's say this is the wind pressure calculation. Right? It's the wind pressure calculation. And the constant formula of the wind pressure that we have to remember every single time. We know that P represent the pressure of the wind, right? It should be 0.5, like 0.5 times, it should be times rho, right? The air density, and also rho should be also times, all of them should be times by wind, the wind speed. Wind speed is given, wind speed is given, and this wind speed should be over the power of 2, right? And also all of them, right? All of them should be times CD. CD, as I said before, CD is the drag coefficient, right? And this is the formula of P, right? So this P is really important. The pressure, the wind pressure is really important in designing structure designing, right? And and I need to ask the computer to display my results according to my process, according to my logic, right? So what I'm gonna do, I need to come up with a code that's allow the computer to generate, to display the results, right? So I'm gonna say display part. The next step is about displaying, right? So display, and okay, let's say display results, all right, all right, all right. And I need to display only two results. I need to display the winds. I need to display the air density and also the wind pressure, right? So I'm gonna start with this DISP means like is the shortcut of display, right? And I need to, first of all, I need to display. I'm gonna open the parentheses and the brackets. I need to display the air density. The first one is the air density. The air, right? Density. The name is the air density, right? And this air density should be represented by rho, as I said before, right? By rho, and the value that should be founded here, right? The value that can be found here should be also converted into a string number, right? Because all of the number here, they're gonna be string, so it should be uniform. So you can multiply dogs and cats, right? It's impossible, right? So we have to I need to convert this value here into string value. And how to convert it? So in order to convert it, I'm gonna use the formula str, right? I'm gonna use the formula str here. So the second part is about to convert. So I'm gonna go to num means the number. Like I'm gonna go to the string. To tr is to convert row, right? To convert the value of row, right? Convert the value of row. All right, and the units also, the computer should display the unit of row. So, and the unit of row, of course, is kilogram meter cubic, right? Kilogram meter cubic. Let me do this, right? And yeah, and it's okay, and it's over. So this is the first display. I need to do the same structure for the next display, and the next display is about the pressure, the wind pressure. So I'm gonna just copy these parts, and I'm gonna set for the new line. So our new line, I'm gonna just paste it, but I'm gonna modify the parameters. So these parameters here should be the wind pressure. So it should be the wind pressure, wind pressure. So the name is the wind pressure, and it should be represented by P, as we said before, by P, and the number of P, should be also converted into a string number. So I'm gonna use the formula, this formula here, but here I'm gonna use P. And of course the unit of P, the pressure, of course the unit of the pressure is the is Newton, Newton meter square. Can be meter square, right? Meter square here, right? And it is all about the displayment place, or the display part. And after displaying here, right, I need to calculate the rho. I didn't calculate the rho. I just gave a formula that this formula should include the air density, should include also the altitude, the temperature, and the humidity, right? So after reading a lot of codes, you have to find out which formula that includes rho can be used in order to find the altitude, the temperature, and the humidity, right? And then you can use it vice versa, right? So if you have the humidity, how can you find the rho? So you have to use those formula in order for you to find the air density, right? So I'm gonna start by saying so the last step is about to calculate calculation of air density, right? Of air density, and from here, according to the International Standard Atmosphere Model, I know that I can create a function first before I come up with the formula. I can open a function because I have three different formula for rho, so I can create a function. Let's say if the function name is rho, right? And rho includes, as I said before, includes Do you remember I say include everything here, right? I'm gonna just copy this one here. Row include everything like altitude, temperature. I'm gonna just copy it and I'm gonna paste it here. I'm gonna paste it here, right? So row. So our function means row equals to air density, the altitude, the temperature, and the humidity, right? And the humidity, I'm gonna close it. I'm gonna erase that part. And then next, right? According to the International Standard Atmosphere Model, right? I know that the pressure, this is the constant formula. They can change. It's 1325, right? And this number should be multiply. This number should be multiply one minus one minus 2.2, right? 2.2. It's 2.3, right? 2.3, and this should be e the power of 5, all right? And it should be times the altitude, right? Times the altitude, right? So here altitude is not unknown anymore because we can find the pressure according to the altitude, right? So and after that, and after this, right here, I know that the formula is not over yet. I need to put the power of 5.255, right? 9. All right, and for the second part, here, according for the water vapor pressure, right? We know that the saturation means there's water, right? Saturation means that wet liquid wet surface, right? For the saturation pressure, let's say for the saturation pressure, right? We can find the temperature here. We can find the temperature in order for us to find the pressure, right? So we can calculate the temperature. Because the temperature is given, the altitudes they are given, the humidities are given. Our objective is to find the different pressure, right? So the saturation pressure here, right? It should be taken according to saturation pressure. It can be taken 6.11, right? 6.11. It can be times. It should be times by 10. By 10, the power and the power should be 7.5 times the temperature times the temperature, right? Times the temperature, and it should be divided. It should be divided by 237, right? 327. Sorry, should be divided by let me do this. It should be divided by 237 0.7, please. Sorry, 0.7, and this value should be added. I mean, temperature should be added here. Temperature. All right, and temperature should be added here, right? And I need to close the parentheses, right? And as you can see here, the humidity become a problem here because we don't have any function. Also, we don't have any pressure formula that include the humidity. For the temperature is checked, the altitude is checked, right? So there's no any problem for that. So we need to come up with another formula that include the humidity. Well, we know that the vapor pressure, right? In physics, and also in according to the International Standard Atmosphere, right? Atmosphere model. We know that the vapor pressure, right? The vapor pressure equals to humidity, right? Equals to humidity divided by 100, right? Divided by 100 times the saturation, like times this one here, the saturation pressure, right? The saturation pressure. So saturation pressure, right? So the vapor pressure equals to humidity. The percentage of humidity times the saturation pressure, right? And I don't want to display it, so I'm gonna just press it here, right? And also we need to find the rho now. Since you have all of the given already, we find the formula that includes all of these three parameters, right? So we need to find rho, right? And we have to find the like the ideal gas law, right? Like we have to find the specific gas constants from the dry air, and it's R. Like it's R. And the constant number of R here, the R is a specific gas constant for dry air, all right? Is the constant number is 2.87, right? Uh, dots like 0.58, right? If I don't make any mistake, right? And the value should be joule kilogram times K, right? So I don't want to display it. I'm gonna just press it here, right? And also the final given, like the final formula here equals to rho. Rho equals to the pressure, right? Rho equals to the pressure. This pressure here that we found. Do you remember the pressure here that we calculate before we give the formula? We gave the formula before. So this pressure minus 0.378, right? 0.378. 378, and then should be times multiply the vapor pressure, the vapor pressure, and this vapor pressure, like all of these these parameters should be divided, right? Should be divided by should be divided by the constants for the dry air, right? It's the R, right? And this R is also multiplied by the temperature, right? By temperature plus 273, right? 273 times 115, and I need to close all the parentheses, and yeah. And also I can close my formula. I can close my function, right, by putting n. This n is for closing my function. It means there is no any other inputs, right? So it means that this is the end of the function, right? And if I want to check how much is the pressure, the wind pressure, all right? So I need to run my formula, right? So I need to assure that there's no any problem here, right? Here the vapor pressure. We have to make sure vapor pressure. Oh yeah, let me do this. Let me change the V. All right, vapor pressure. All right. All right. I think there's not any problem, right? So, okay. Okay. Let me run my function. I'm gonna go on A0, and I'm gonna run my function. Yeah. I'm gonna name my function. Let's say I'm gonna say display. I'm gonna display R, small r, rho, right? And I'm gonna save it. And the result should be shown. The result should be shown. Oh, there's a problem here. So the cell line. So even if you have a problem, right? You have to modify the problem. So here they say that row, like the line 33 has a problem here, right? Yeah, the line 33 has a problem. So I need to modify the line, right? All right, so we can check the problem. Like if we run it again, let me run it first. Let me go to A0 and run it again. You see, there's a problem, right? The same problem, that line 33, right? So the problem is, as you can see, we have this value here, this parameter here is underlined, right? So it means that it should be defined somewhere, right? So this vapor pressure and this should be the same, should be identical, right? So as you can see, maybe we right hand this parameter here, right? So we have to check if there's no capital. Yeah, I put the capital letter here, right? Yeah, I didn't put the capital letter, so I can just remove the capital letter and then put the, now they're matching, right? They're the same. You can see that if I put on temperature, you mean this temperature, they're almost the same, right? And if I put on vapor pressure, you can see that this vapor pressure and here, they're the same, right? So it means that there's no any problem. If you account another problem, is that you have to modify the data, right? But I'm gonna check it again. So I'm gonna press CLS, right? CLC to clean the command window, as I said before, right? right? And here, I'm gonna go and again on 80 and then run. And now we have the results, right? For the air density, we know that the air density here is given. The number is 1.1 or 1.2, right? Kilogram per meter cubic. And for the wind pressure, we also have this value, 629.8 Newton by meter square. So this is how we can calculate the wind pressure and all the unknown that should be calculated before you find the wind pressure, right? So if you have any problem, you can just comment, and don't forget to share the video, and don't forget to like the video, and also the most important, don't forget to subscribe to this channel. See you in the next one. See you in the next one.